All right, we got a quick theorem. So this is a theorem, derivative of linear and constant functions. So we want to say derivative of linear and constant functions. So we'll say if, be the first little thing, make a little box there or something. So if f of x equals mx plus b, so pretend that's a linear function, say is a linear function, then the derivative at a just equals the slope of the line for all a. So basically, if you're trying to take the derivative of anything in y equals mx plus b form, the derivative for that form is always just the slope of the line. Part B, or second box, I guess. If f of x equals b is a constant, then f prime of a equals 0 for all a. So the derivative of y equals mx plus b stuff, the derivative of lines, is just the slope of the line. And that, you kind of could see that because if you have a line, say a diagonal line that's straight, if you try to draw the slope of the tangent line, it's going to be the line itself, so you get back the same slope. And if f of x equals b is a constant, then f prime of a equals 0 for all a. So if you have a constant are horizontal lines. So if we have a horizontal line and you try to be tangent to a horizontal line, you're another horizontal line, and horizontal lines have slope 0. So that's why the derivative of constants is 0. Or you could think of it in terms of tangent slopes of tangent lines to get those results. Okay, so let's do a quick example. This is example 4, using our information there. So we got f of x equals 9x minus 5 at, and we're going to say, so f of x is that. We want to find f prime of 2 and f prime of 5. Well, this is a linear function. It's y equals mx plus b form. So the derivative at any a of a form like that is just the slope. So it's just going to be 9, and that'll be the same thing as f prime of 5. That will also be 9. The slope of the line, it's the m from the y equals mx plus b form. And that's really all there is to that example. So that one's pretty quick.